All right, so I wanted to make sure I actually had these graphs labeled correctly. So this is A and this is B right here. Sorry about that. Now we want to know what is happening in this position versus time graph. So notice because this is position versus time, that tells me that there's no acceleration because when there's acceleration, position graphs are curved. Now if you remember, steeper equals faster, and we know that since we're moving this way, we're moving backwards. So let's see what it says. And backwards or negative is the direction of motion. So we're not moving in the positive direction at all. So I'm just going to actually cross this out. We're not moving in the opposite direction either. So let's be really clear. So both A and B are moving, and they're moving at a steady speed. So that means this is right. Now, how do we know A is moving faster? Let's remember, since A's slope is steeper, that's how we know it's moving faster. So the answer is going to be A for number 1. Now, for number 2, again, this is a position versus time graph. Again, there is no acceleration because the graph isn't curved. This is a position versus time graph. So let's be clear. We are moving at constant velocity the whole time. And so we are definitely moving. We are not moving backwards. We are not, so this is a positive position. We're not starting from a positive position, so there's only one right answer left. We're starting in a negative position, and we're moving forwards, and we're doing so at a steady speed. So that's why choice A is correct. And for number 3, what is the object in this position versus time graph doing? Again, this is position versus time. When you see a flat line like this, that's an indication that it is not moving. That actually eliminates the first 3 choices here. Again, because I'm at a fixed position here, and I'm just staying there as time goes further and further. So basically what's happening is we're at a negative position, and we're just sitting there not moving, and that's choice D. Then for choice 4, we want to get the displacement between 3 and 8 seconds. So that's going to be the final position here, which looks like I'm at 8. And the initial position here is 28. And displacement is x final minus x initial, which is going to be 8 minus 20. So I'm actually going to get a displacement of negative 20 when I work this one out. I think I might actually skip this on the final. And I'm curious as to see how many people are going to ask me about this on Friday. So this will actually be a good indication of whether you watch the videos or not. So number 4, I'm going to actually not answer questions about in class, just to kind of see who's actually watching my videos. So I am actually not going to put a question like this on the final. So for those of you that see the video, you'll kind of have a little extra clue. All right, so for number 5, what is the object's position at 5.5 seconds? So let's take a look. At 5.5 seconds, it looks like I am here at the 18 meter mark. Let's see if that's a choice. It is indeed a choice. We are at 18 meters. So in the next video, I'll do the next 5 problems. Actually, you know what? Let me try to do just a couple more. So we want to know what is the velocity of the object. Well, to get the velocity, we're going to need the slope. So that is, let's see, let's go from 8 to here, and that's from 8 seconds to 3 seconds. So if I were to get the slope, that's going to be rise over run, and that's going to be 8 minus 28 over, and let's get the time, that's from 8 to 3, so that's going to be 8 minus 3, so that's going to be negative 20 over 5. I'm getting negative 4 meters per second. Where was the object at 0 seconds? That's a really good question, so let's see if we can actually figure this out. So we know that x is going to be v naught t plus x naught to get the equation of motion, and we know that x is going to be negative 4t plus x naught. Now let's see if we can actually figure out what this x naught is by plugging in a number. So I know, whoops, wrong page. I know that at 8 seconds we're at 8, so let's plug that into the formula. So I know 8 equals negative 4 times 8 plus x naught, and then when I solve, I'm going to get that x naught is actually at the 40 meter mark. Excellent. So in the next video, we'll do a few more problems. So we've done 1 through 7 here. and that should be a good guide to get started.